Okay, so this is for the advanced 8th grade pre-cal kids, so that would be Isaac and Jaree. So we got some patterns here for lesson 9-2, and they want us to pick one and to extend the pattern out with drawings and also make a table and find the constant difference. So I've picked pattern C. I already have a table set out with all the information, so the X's are my figures and the pebbles are my Y values here, and I already have that set out. So I'm going to extend it out more, right? So if we got figure 3 here, that's got, let's put here figure 4. And figure 5, we've got 1, 2, 3, 1, 2, 1, 2, 1, 2, and if we want to extend it out, if you notice, you can see that it adds 4 each time, so it adds 1 more to each end. So I'm going to add another one to each end. So that means that instead of it being 9, it's going to be 13 now. If you count, it's going to be 13. And then let's go ahead and do figure 5. So again, we got 1, 2, 3, 4. So we're going to put out 1, 2, 3, 4 on each side. Let's see. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 4. And then I got 1 more on each one. So that's going to give me 17. So again, like I said, if we're adding 4 each time, that's our constant difference. Our constant difference is 4. So go ahead and put that here, constant difference. Alright, so let's go to our next page. Let me see here. Okay, so here's the back of that. So it says describe the pattern in words. So just like we were saying, a pebble is added. Oh, sorry, let me get it focused, sorry. A pebble is added to each end let's put and there are 4 ends. And this is for pattern C. Okay, and then we have to write an expression using the variable n that could be used to determine the number of pebbles in figure n. So before we can do that, we gotta figure out what the starting value was. So we know that our constant difference was 4, so we're going to start out with that. That's going to be next to our variable x, and then our starting value that from the pattern was 1. We started out with 1, right? So when x is 1, when x is 1, our y was 1. So that's what we can use to get the actual starting value when x is 0. So what we can do is we can put in here -1 for x, and that will give us our very starting value, very first starting value when x is 0. So 4 times, sorry, when, yes, it's 0. So 4 times -1 is -4 plus 1. That's going to give us -3. So that's going to be our starting value. So we're going to use that in our actual expression. So now I'm going to write my actual expression, which is going to be y equals 4x minus 3. So this is my equation. So if I want to figure out what my pebble is, alright, number of pebbles at the 10th figure, the 53rd, and the 200th, all I have to do is plug it into this formula. So we got 4 times 10 minus 3 for this one. So 4 times 10 minus 3, that's going to be 40 minus 3, which is going to be 37. And then for this one, we're going to have 4 times 53 minus 3, which I'm going to have to do that work over here. So 44 times 53, that's going to be 12, 21. So 212 minus 3, that would give me 199. And then we have lastly 200, so 4 times 200 minus 3, which gives me 800 minus 3, which would be 797, I believe, yes. 797. Okay, and it says for the pattern you selected, is it possible to have a figure with 100 pebbles? Explain your reasoning. Well, let's think about this. Is it possible to have a figure with 100 pebbles? Well, multiples of 4 will always be even. But if you then subtract 3 from an even number, it will always be odd. So it can never be 100. Okay, and then based on the class's work, how does the constant difference in the pebble pattern relate to the algebraic expression that can be written? You're going to put the constant difference is the coefficient of x, or n. Actually, we should probably change this up here to not x but n. So they said they wanted it to be an n. N. Okay, sorry, it's blurry. Let me try to fix that. Okay, so hopefully you got all of that. hopefully this is something that you've done before, where you multiply -1 to get your starting value and then put it into the algebraic expression. If not, we'll do it more times and you'll get used to that. Okay, so let's go to the next page. I'll go through this. So we're on to page 113. And let me just go over this again. Okay, sorry, I had some notes on there from before, and I had to erase that. So some of the stuff that I write is going to be different, so hopefully you didn't write any of that. So we're on 113. And it says check your understanding. It says what is the constant difference for each pebble pattern shown in the tables. Okay, so our constant difference here for this one, you can tell this is 4 again. For this one, we've got 5. So we're going to put 4 and 5. There's 4, here's 5. For each pebble pattern, use the variable n to write an expression for the nth figure. Okay, so we're going to write an equation. This is going to be in front of the x value, but they want us to write n, so it's going to be 4n. And we got to figure out what the y is when x is 0. So instead of doing that whole -1 thing, you could also just think to yourself, okay, so if I go back 4 to get what the y is when x is 0, let's see, what would 3 minus 4 be? Right, so let me think, what's 3 minus 4? That would be -1. So that's going to be my actual starting value from 0. So that's what's going to go here in my equation. Sorry, hopefully you can see that. So you got 4n minus 1 for the first one. And like I said, you got to figure out what that value is when x is 0. So what we did is I just took that common difference to go back, right? So instead of adding 4, I subtracted 4 from 3 to get -1. Okay, so now for pattern B, our constant difference is 5, so this is going to be 5 here with the n. And I need to find out what the y is when x is 0. So if I, instead of adding 5, I actually subtract 5. What is that going to be? So let's see, 2 minus 5, what is that? 2 minus 5 is going to be -3, right? So I'm going to put here -3. So those are my equations, or expressions. How many pebbles are in the 50th figure for each pebble pattern? So let's see, so 4 times 50 minus 1. Can you see that, or is it glare too much? It's hard to focus where you can see. So 4 times 50, that's going to be 200. 200 minus 1 would be 199. And then we have 5 times 50 minus 3. And that's going to give me 250 minus 3 would give me 247. It says both pebble patterns have 7 pebbles in figure 2. If the patterns continue, will they ever have the same number of pebbles as another figure? Explain your reasoning. Let's see here. I would have to say no. here because let's say no, because pattern B is getting increasingly bigger. But you can put whatever you would like to put there. On number 7, it says the Pythagoreans also studied the following pebble pattern. How many pebbles are there in the 4th, 5th, and 6th figures? Well, we can just extend this out. So this is 1, we got a 2x2 box, we got a 3x3 box. So our next one would be a 4x4 box. So to figure out how many pebbles there are, let's just get the area. 4 times 4 is 16, right? So figure 4, 16 pebbles. The 6th figure, well, if the 5th figure would be 5 times 5, the 6th figure would be 6 times 6. There. And so that would be 36. Does this pattern have a constant difference? It does not. If you look at this, this is between 1 and 2, we got a difference of 3. Between 2 and 3, we have a difference of 6. And 5, not 6, 5. Okay, hold on 1 second. Okay, sorry, my battery had was low, so I had to plug it in. B says, does this pattern have a constant difference? Explain your reasoning or your response. The difference here is 3. Here was 5. On this one, it is 7. So if you can see, it's not constant. So we're going to put no. Explain your response. The differences are not constant. Or not the same. Describe the pattern in words. Well, if you can look at it, you can see that it makes a square, right? So it's each side is the number of the figure, right? If we're on figure 2, then the sides of the square are that same number. So it's the n, right? The value of n times the value of n. Same thing here. We have the value of n, or the number of the figure, times that same value up here. And that's the pattern that keeps showing up, that the side value and the top value increase by 1 each time, right? And it's the same number that the figure is. So we could put here the shape is a square. Shape is a square. With side lengths of n. Whatever the n is, that's the side length. How many pebbles are there in the 10th figure? How do you determine your answer? Well, if n equals 10, then that means the number of pebbles is going to be 10 times 10, which will be 100. Okay, and at this point I'm going to stop, and we'll do the rest tomorrow. And you can start on your 9-2 practice and get to where you can. And, well, again, like I said, start on this tomorrow. All right, I hope that was helpful. And you guys have a good day.